today's class, let us understand about voltage division rule. Voltage division rule and how it works. In order to understand the voltage division rule, let us consider a series circuit with two resistances connected in series with the voltage source V, current I, resistance being R1 and R2, the voltage across each resistor being V1 and V2 respectively. So you can see in the circuit R1 and R2 are connected in series, hence we can write R equivalent is equal to R1 plus R2. Now from the Ohm's law we know that V1 is equal to I R1, V1 is equal to I into R1, equation number 1. Similarly, V2 is equal to I R2, equation number 2. So we can say that V is nothing but is equal to I into R equivalent, that is total resistance. Hence we can rewrite this equation as I is equal to V by R equivalent, or V is equal to R equivalent is R1 plus R2. We shall call this as equation number 3. Now substituting this 3 in equation number 1, what we get? So equation number 1 says V1 is equal to I into R1. So we get here V1 is equal to I. So R1 divided by R1 plus R2. Similarly, V2 is equal to I into R2. Substituting the value for R, we get here V is equal to R2 divided by R1 plus R2. So you can observe here, if it is V1, voltage across primary is equal to total current into resistance, same resistance divided by total resistance. Similarly here V2 is equal to R2, opposite same resistance divided by total resistance. So the voltage division rule is only applicable for series circuits. We must understand that it is only applicable for series circuit. So what does this voltage division law state? The voltage division rule states that the voltage drop across any resistor is equal to the total voltage into resistance where you want to find the voltage drop divided by the total resistance. Similarly, now let us find current division rule. Before current division rule, let us analyze about parallel circuit, parallel resistance. When it is called as parallel, let us understand. Now this circuit is called as parallel circuit. R1, R2, current is divided here. The total current is divided into two parts, I. Now this is your voltage V. Now if both the ends of the resistor are common, then they are said to be in parallel. Now you can observe that both the ends of the resistance are in common. Now we can say that from the Ohm's law, the voltage drop across R1, which is equal to V is equal to I1 R1, and the voltage drop across R2 is I2 R2. Similarly, we can say I is equal to V divided by R1 and I2 is equal to V divided by R2. Now if we apply KCL, here I is equal to I1 plus I2. So from this, if we substitute for the voltage, V is equal to R equivalent, V divided by R1 plus V divided by R2. Now taking out V common, 1 divided by R1 plus 1 divided by R2. So we can say here 1 divided by R equivalent is equal to 1 divided by R1 plus 1 divided by R2 in your parallel circuit. Now using this, let us find now current division rule. This current division rule is applicable only for parallel circuits. We must remember it is applicable only for parallel circuits. Just now from the parallel circuit we obtained I1 is equal to V1 by R1, equation number 1. Similarly, I2 is equal to V2 by R2, equation number 2. Now we know that V is equal to I into R equivalent. So R equivalent is nothing but R1 R2 divided by R1 plus R2. Let us consider this as equation number 3. and this is equation number 4. Substitute this equation 4 in 3. So we get V is equal to I into R1 R2 divided by R2 plus R1. So next, substituting the equation 5 in equation number 1, we get I1 is equal to V divided by R1, that is I into R1 R2 divided by R1 plus R2 divided by R1. So cancelling out the common terms, what will remain here? I into R2 divided by R1 plus R2. Similarly, we get I2 is equal to I into R1 divided by R1 plus R2. So what it says? The current which is flowing through any resistor will be equal to total current multiplied by the opposite resistor resistance divided by the total resistor. This is what your current division law says. Hope you understood. Thank you.